In this example, I need to rationalize the denominator in the expression the square root of 3 plus 2 all divided by the quantity the square root of 2 plus the square root of 3. Well, looking at the denominator, how many terms are there in the denominator? There are 2 terms in the denominator and they involve square roots. So how do we rationalize problems that look like this? To rationalize a denominator that contains a binomial expression involving square roots, we need to multiply the numerator and the denominator by the conjugate of the denominator. So in this case, I'm going to multiply numerator and denominator by the conjugate of the square root of 2 plus the square root of 3. How do we find the conjugate? You keep the first term the same. I'm going to have the square root of 2. The last term is the same, the square root of 3, but I have the opposite sign between them. Since this was a plus, this has to be a minus. Since I multiplied the denominator by the square root of 2 minus the square root of 3, I must multiply the numerator by the exact same thing, because all I'm really doing is multiplying by 1. I'm not changing the value of my expression, I'm just changing its format. So now all I have to do is simplify. I think it helps if I put these binomials in parentheses, because now I'm going to multiply across and I'm going to use FOIL. So in the numerator, my first terms are the square root of 3 times the square root of 2. Since they're both square roots, I can multiply them and I can multiply the 2 radicands. So I'm going to get the square root of 3 times 2 is 6. Outer, the square root of 3 times negative the square root of 3 is minus the square root of 3 times 3 is 9. Inner, 2 times the square root of 2. This 2 is outside the radical. This is inside. We can't multiply them, so I'm just going to get plus 2 times the square root of 2. And then last, 2 times negative the square root of 3, which is minus 2 times the square root of 3. All divided by, now in the denominator, I'm multiplying conjugates. So we know we should get the difference of 2 squares, but I'm just going to FOIL it out to prove it. First term, the square root of 2 times the square root of 2. So I'm going to get the square root of 2 all squared. I could write that as the square root of 4, but I'm trying to show that I get the difference of 2 squares, so I prefer this notation. Outer, the square root of 2 times negative the square root of 3 is negative the square root of 6. Inner, the square root of 3 times the square root of 2 is plus the square root of 6. And finally, last term, the square root of 3 times negative the square root of 3 is negative the square root of 3 all squared. Now, can I simplify any of the radicals in the numerator? The first term, the square root of 6, is in simplest form, minus, but the square root of 9 is not. The square root of 9 is 3. 2 the square root of 2 cannot be simplified, so I have plus 2 times the square root of 2 minus, and the last term, 2 times the square root of 3, also cannot be simplified. Now in the denominator, I have the square root of 2 all squared, which is 2. Then I have minus the square root of 6 plus the square root of 6. Those two add up to 0. Which is what I was hoping for, minus the square root of 3 all squared is 3. So notice in the denominator, I have the first term squared minus the second term squared. So I landed up with the difference of 2 squares. Now, can I simplify the numerator? Can I combine any of these radicals? All the radicands are different. I cannot combine them. So I'm just going to get the square root of 6 minus 3 plus 2 times the square root of 2 minus 2 times the square root of 3. All divided by 2 minus 3 is negative 1. So now all I have to do is divide all 4 terms by negative 1, which just means I'm going to change all their signs. So I get negative the square root of 6, opposite signs, so plus 3, minus 2 times the square root of 2, plus 2 times the square root of 3. I can't combine any of those terms, so that is the answer when I rationalize the denominator of my expression.